All right, welcome to this video. So today I'm going to go over some of the factors that can increase the strength of your print. So those would be infill, perimeter shells, layer height, and extrusion width. All right, so should we increase the infill density, or should we increase the number of perimeter shells? For instance, you could print this part. You could add material by, increasing the infill versus increasing the number of perimeter shells. And when I talk about perimeter shells, I also mean top and bottom shells to have a homogeneous surface thickness. So the data says that you can reduce weight and maintain your strength if you increase the perimeter shells, which is really cool because you can use less material. All right, so the blue line, we see a general trend that if you increase the infill, you can increase the strength. Likewise is true and more effective is if you increase the weight in the perimeter shells. So there you go. That is a very compelling graph to start using perimeter shells rather than increasing the infill density. If we look at print time, we don't see a benefit in either direction using infill or perimeter shells. For the same strength, it takes roughly the same amount of time to print. Now, this is a very interesting chart here. We see strength per weight on the left-hand side. And if you notice here, 100% rectilinear with two perimeters is less effective in the strength per weight ratio than 15% rectilinear with four perimeters. So it's actually very comparable to the 15% rectilinear with three perimeters. So that's very cool. And we see this trend increase, all right? So we see 6 perimeters over here with 15% rectilinear, and it is the strongest out of all of these. Another thing to note is that, full honeycomb is, said to be one of the strongest infills, and at 75% and 2 perimeters, it is nowhere close to comparing to these varieties over here, even though the perimeter or the infill is so much more dense. So what does that tell us? If you want to increase the strength of your parts, think about adding perimeters. All right, let's transition to layer height. So layer height is, the distance between each layers, all right? So you can have really fine prints and you can have very coarse prints. Now there's two kind of concepts I want to go over here, and that is print direction and layer height. Okay, so print direction can affect strength greatly. This hook that was printed in the XY plane is way stronger than the hook that was printed in the Z plane. All right. So that's because you do not get full adhesion, and you get stress risers at each one of these kind of points here. So that's due to adhesion issues and stress riser. Every time you have a little bump or a little crevice in a material, you introduce a stress riser and it makes the part weaker. All right, so what do we see here? What is the effect of layer height? Well, at lower layer heights or finer layer heights, we see that the part is stronger and it starts to drop off as that layer height increases. All right. But still, in this region right here, they are very comparable, I'll say. All right, so that is, in the XY position. So let's take a look at the results, the, kilograms per gram of material for the Z direction. All right, so again, we see a very sharp drop off here, and we see some comparable results. And we actually see an increase. The most effective is 0.15 millimeters. So I would suggest think about having a layer height of 0.1 to 0.15 millimeters in height. Now, another thing that can affect the strength of your part is extrusion width. The extrusion width is the width of the material that's extruded on a layer. All right, it's shown right here in this image. And it's usually a percentage or a value relative to the nozzle diameter. So the nozzle diameter of our machines is typical of many machines, 3D printing machines, is 0.4 millimeters. All right, and so that would be 100%. If we think about it as a percentage, the extrusion width as a percentage of the nozzle. All right, now these samples right here were pulled, and as you can see, we are pulling in the unfavorable direction, which is the Z height. And what we start to see is really interesting, that it increases. So as we start from 90% of the extrusion nozzle to 140, 160 region, we see an increase in strength, and then we see a decline in strength. So there you go. And we see a sweet spot, right around this point right here, 140 to 160. And I just want to show, what this red line is. This is the material strength right here, at which it fails, which is about 60 MPa. All right, and so we can actually start to approach that if we use an extrusion width of 140%. All right, now the test hooks were also printed with a couple of different variations, and how it's tested is that this pull on the blue hook, and it usually breaks right about in this region right there. All right, so again, we see here 133% with 3 perimeters is better than 4 perimeters at 100%. And so let's just kind of break down the math here. So 0.4 times 1.33 times 3 is a thickness of 1.6 millimeters. And 4 perimeters, 0.4 times 4 is 1.6 millimeters. So we see that at the same thickness, the 3 perimeters that are extruded wider performs better than the 4 perimeters at 100%. And we see that printing at 200% with 2 perimeters is even stronger than the 3 perimeters at 133%. However, we start to see a decline in strength in these other tests that we saw here. So to compile all of this data, I created a little bit of an overview here for you. And so if you want to print for strength, I would start with an infill of 15% and choose, a robust infill that I recommend in another video. You don't actually have to print very densely with those infills. All right, choose at least 4 perimeter shells. This is what the data is telling us. We need to thicken up that surface using perimeter shells. Use a layer height of 0.1 to 0.15 millimeters. Obviously, the 0.15 millimeters will print quicker than the 0.1 millimeter version, so maybe that would be the factor in how you decide those. Then the extrusion width, choose a 0.56 millimeter extrusion width or 140%. So that is how you can increase the strength of your part. Now let's go and do that. All right, so I'm going to head over to Prusa Slicer. All right, so I'm going to go to Print Settings, and I'm going to change my layer height to 0.15. All right, so I'm going to change all of these to 0.15. I'm going to change my perimeters to 4. It recommends starting with top, having a top of 7 and a bottom of 5. I could keep that the same, but just to be consistent, I'm going to change those to 4 and 4. All right, so that's all I'm going to change in this screen. Then I'm going to go to Infill, and I'm going to select 15%. Now again, gyroid would probably be fine, cubic, but I have the data of the rectilinear, so I'm going to choose that one. All right, but again, maybe you need to experiment. Gyroid, cubic, even line would be grid would be excellent choices as well. And maybe I'll give a shout out to triangles too. All right, so that's what I'm going to change there. Then I'm going to go to advanced. All right, so this is where our extrusion width is. And so we can put in percentages or we can put in millimeters. I'm going to put in millimeters, and I'm just going to populate all of these to the 140%. All right, so we're changing our default extrusion width, our first layer, our perimeters, our external perimeters, our infill, our solid infill, and the top solid infill. We're going to change all of that to 0.56. Go to the plater and we'll slice it now. All right, so as you can see, we've increased the perimeter shells. The extrusion material may look a little bit fatter than it used to be because we are extruding more per layer. All right. So now that you know where these settings are, start using them. Start experimenting. See if you can make an even stronger print. We'll see you in the next video.